All right, hello. Welcome to today's class. Of course, you know this is Sigma Tech Consult Limited. We will take a topic in mathematics today, angles. Okay. I want to believe you have an idea of what angles are. All right. You may have seen shapes and angles. So we'll look at angles today and look at. Let's look at some of the objectives I want you to get at the end of this lesson, some of the things I want you to get. By the end of the lesson, you should be able to define angles, mention and then identify types of angles, state some properties of angles, then solve mathematical problems involving angles, okay? So we are going to take this one after the other by definition. I say here that an angle is a geometric figure formed when two rays or lines meet at a point called vertex. Okay? Okay, so I said it means a geometric figure formed when two rays meet at a point called vertex. Let's assume this is a ray of light and this another ray of light. Okay? This ray is coming this way and this one is coming this way, is going, traveling. They meet at a point. You see the point here? This point here is what we call the vertex. Vertex. So an angle, from the definition, we say an angle is a geometric figure formed when two rays. This is a ray. Okay, this ray is traveling in this direction. This one is also traveling in this direction, and they jam or they intercept at this point. Okay, this point where they intercept, they form a space there. That space is what we call an angle. All right. Another definition I have here, I said an angle is the point of interception between two or more lines. The point of interception between two or more lines. It means, look at the board, a line can be coming this way, another line can be coming this way, another line can be coming this way. Now, these are three separate lines traveling. So let's see. This one is traveling on its own. This is traveling on its own. This is traveling on its own. Okay? So you can see that this line and this line and this one, they travel and they intercept as a point. Do you see this point now? So this, you can see that an angle or angles have been formed here and have also been formed here. So we say angle is the point of intersection of two or more lines. I also said that it is the degree of turning at a point. The degree of what turning? If you know what a compass is, okay, the compass is drawn such that it makes a turn. Okay, you put a pencil inside a compass and you try to make a turn with the compass. Okay, now the degree of turning is an angle. So it means that if a compass is placed here and you are turning from this point where the compass is to this point, you have just made an angle. So from this point where it started to this point where it stopped, let's assume that this is a compass that was here and this compass turned to this point. So this imaginary line that you're seeing here, okay, so this is a part of the compass, okay, that it turned to. So this compass turned from here down here. So this place has formed an angle. It means there is an imaginary line from this place of the origin of the compass to this place, forming what? An angle here. So an angle can also be said to be the degree of turning in a particular point or at a particular point. Okay? I said that angle is measured in degrees. Angle is measured in degrees. And degree is denoted as small naught up, small zero up like this. So if I say angle 50 degrees, it means I just write 50 and put small naught on top of the 50. Do you understand me now? All right. So I said it is measured in degrees by a protractor. So an instrument used in measuring angles is a protractor. A protractor is a part of your mathematical set. Okay, that one that looks like this, that is a part of your mathematical set that looks like this. Okay, it is used to measure angles. It is measured from 0, okay, to 180. Okay, so you can measure angles using this protractor. Do you understand me now? And I said angles can also be constructed. Angles can be constructed with a pair of compass, with a ruler, and a pencil. Okay? I think one of our classes will look at construction of angles and other shapes. All right? Then, each symbol, remember, the first one I gave is not, this is not the symbol of angle. This is the unit of measurement of angle. But for degree, angles are symbolized as either this or this. So if I say angle A, I can decide to say angle A or angle A. Do you understand me now? I want to believe that by now you have learned naming angles. Angles can also be named. Now, depending on the angle talking about, let's say we have this kind of angle, okay? Let's assume there is something else. Let's say this is A, this is B, and this is C. Remember, it's like we have two angles here. We have an angle here, and we have an angle here. Okay? Now, and let's say we have, let's say O here. This is the origin of these angles, O. So, angle A, we have here, we have angle AOB, and we have angle AOC. We also have angle BOC. So, depending, if you want to name this angle, you must use these symbols of the angle to name the angles. So, if you want to name this angle AOB, this is what? Angle AOB or angle AOB. We put this one, this other symbol, if you want to use this style, we are in the middle of the two angles. So it means that this angle is talking about where line A and B make intersection at O. Okay, that is what that means. Okay, so you must understand that about angles. Okay, so we have taken the definition of angles. I've taken the unit of measuring angles. Okay, we have taken how angles are constructed, how angles are measured. We have looked at the symbols of angles. The next thing we should quickly look at is types of angles. Okay, so let's take types of angles. You need to pay very clear attention to these types of what? Angles. Types of angles. Now, there are different types of angles. Remember, this, when we say angle, is the degree of turning. It means that if the compass is turning, it can turn to form a particular size of angle. So, depending on the sizes of the angles that we have, it brings us to the types of angles. The types of angles will really have to do with the sizes of the angles that we have that will determine what type of angle it is. Okay, so we have the first one here, types of angle. The first one is acute angles. Acute angles. Acute angles are angles that are less than 90 but greater than 0. So angles between 1 to 89 degrees. Angle between 1 degree to 89 degrees, they are called acute angles. So you may be asked in your exam, they may give you an angle or a figure between 1 to 89 and ask you what type of angle is that. Okay?
So any angle that is less than 90 degrees but greater than 0 is what? An acute what? Angle. All right. The next one is, so we have angles like angle, let's say angle 20 degrees, angle 30 degrees, 50 degrees, 70 degrees, 80 degrees, 89 degrees, and so on. So we have so many of them. So all these things are acute angles. Once they are not up to 80, they are acute angles. The next one is the right angle. Right what? Angle. Right angle is an angle whose value is equal to 90. Exactly equal to 90. It means 90 degree. It means that 90 degree is called right angle. It means if anybody tells you right angle, that angle is right angle, that angle is right angle, that angle is right angle, just know that the person is saying that the value of that angle is 90 degrees. Do you understand me now? If they tell you that that angle is two right angles, it means 90 times 2. Do you understand me? If they tell you 3 right angles, it means 3 times 90. 4 right angles, 4 times 90. Okay? All right. So any angle that its value is exactly 90 degrees is what? Right angle. Okay? All right. So the next one is obtuse angles. Obtuse angles. Obtuse angles are angles greater than 90 but less than 180. These angles are what? Greater than what? 90 but less than what? 180 rather. So it means obtuse angles begin from 91 degrees to 179. So to 179 degrees. So any angle you see between 91 to 179, they may ask you, what kind of angle is this? The answer is what? Obtuse angle. Obtuse what? Angle. All right. So obtuse angles greater than 90 but less than what? 180. All right. So we go to the next one. Angles on a straight line. All right. Angles on a straight line. Angles on a straight line are angles whose values sum up. When you sum them together, they give you 180 degrees. Angle on a straight line is just like when you have a straight line like this. And remember I told you, it is a protractor that you use to measure angle. If you put your protractor here, your protractor will give you this sign. It means this sign, I told you before that from here, from this 0 point to this point, from here to here is 180. It means all the angles we have inside here, any number of, even if it's 1, 2, 3, 4, whatever, even if we have just like this, here and here and here, okay, all these angles, they say the summation of them, addition of all of them gives us 180 degrees. So sum of angles on a straight line, because this is a straight line that this protractor is. So sum of its angle is 180. Do you understand me now? They can also, another similar way of asking you this thing is sum of angle in a semicircle. A complete circle like this, okay? Sum of angle inside a complete circle, we are coming there, okay, is 360. So half of a circle, because a straight line gives us half of a circle. This is half of a circle. So we are saying sum of angle inside half of a circle is 180 degrees. Do you understand me now? So sum of all the angles here is 180 degrees. So angles on a straight line is usually equal to what? 180 degrees. Okay? So let me just give you something there. Like in some exam question, they may give you something like this. Listen, and they give you let's say they give you an angle here and tell you that this is 100 degrees. And they give you that this is 100 degrees. And they also give you this angle and they mark it X. And they ask you what is the value of X. Remember we say sum of angle inside, this is a straight line like this. All these things, they are inside one straight line. See them now? They're inside a straight line. So if this part from here to here is 100, it means to complete the other part of the distance, this other part will be 80. So that 80 plus 100 should give us a total of 180 for the sum. Okay, we'll get to that when we begin to take examples. All right, so reflex angles is another one. Reflex angle is another type of angles. Reflex angle or reflex angles are angles greater than 180 but less than 360. Reflex. So we said angle, this one is angle on a straight what? Line. And we said it's equal to what? Each sum is equal to 180 degrees. Then 5, we said reflex angles sum up, okay? Reflex angle and angles greater than 180, that's from 181 degree to 359 degrees. Remember they said their angle greater than 180, that's from 181 to 359 degrees. Those angles are called reflex angles. Then the next one is angles at a point. Angles at a point. Okay? 6. Sum of angles at a point. At a point. Their sum is equal to 360 degree. Meaning, if this is a point, we are saying that if an angle is made here, and made here, and made here, do you understand? And made here, this is an angle. This is also an angle. This is also an angle. This is also an angle. All these angles here, let's say if this is A, B, C, D, okay? It means that A plus B plus C plus D must be equal to what? 360 degrees, because this angle at a point is also called complete angles or revolution angle. Okay? This angle is the angle that if you're using compass, it starts from an origin and turns and go back to its origin. So it forms a complete circle. It means that a complete circle is 360 degrees. That is what forms a complete what? Circle. So we said sum of angles at a point or sum of angles inside a circle, because if you look at this point I made here, all these angles, see, I made a point here, made a mark. What shape are they forming for you there that you can see, even if it's not formed very well? It's a circle, a circular shape. It means sum of angle inside of this circle is what? 360. So sum of angles, they can ask you sum of angles in a circle is what? 360. Or they can ask you sum of angles at a point is what? 360. They are also called complete angle or revolution angles. All right? Okay. So I have a picture here for you to see the different angles. The acute angle, as you can see the picture there, okay? We say it's from like 1 to 89. So this is what a right angle look like, okay? That is a right angle there is equal to 90 degrees. So it always has a symbol. This symbol is like a ladder that someone, or a chair that someone sits on, okay? Once you see that kind of symbol in mathematics, that's angle 90. So obtuse angle, when an angle measures between 90 and this, okay, obtuse angle, then for straight line angle, look at the symbol here, okay? Then for reflex, look at it here. It's not up to 360, but it is big, okay? Then complete angle or full rotation angle, look at it here. If you can see, you have these two arrows meeting at a particular point. This arrow has gone and still come back to meet where it started. Okay? So that particular angle
is known as angle at a point. So let's just look at briefly some properties of angles. Okay, there are some properties of angles that you will need to consider in mathematics, because the questions they will give you in mathematics will be drawn from your understanding of the properties of angles. So properties of angles. Okay, so the properties of angles, some of them I have mentioned them, I will mention them again. The first one says sum of angles on a straight line is equal to 180, and I've explained that to you. Okay, what it means is that if we have, listen now, number one, sum of angle on a straight line. Okay, so if we have an angle, a straight line like this, okay, and we have an angle formed like this, okay, so this, let's say these are A, these are B, and these are C. So this angle property says sum of A plus B plus C must be equal to what? 180. Even if you have 4 angles, 5 angles, 6 angles, 1 and 2 angles, their sum must be equal to what? 180. Do you understand me now? All right. So it means that that is a property of angle that you must know. Is a theorem that you must understand very well. The second property is sum of angles at a point is equal to 360. I have also mentioned that at a point here, 1, 2, 3. So this is A, B, C. So this property is saying A plus B plus C is equal to what? 360 degrees. All right? All right, then the third property. So what this means is that when you add all this one, is 360 degrees. All right? So if we have the next one, we say sum of angles in a right angle is 90. How? We said this is our right angle, how it looks like, right? It means everything here, we said this thing is 90 degrees. So if we have other angles here, first of all, you know that this is a right angle, and we have an angle here, and we have an angle here. Okay? Let's say this is angle A, angle B, angle C. Okay? What this means is that A plus B plus C is equal to 90 degrees. Do you understand? So this is different from this and this. Okay? So sum of angles inside a right angle. This is a right angle. Okay? So if we have other angles inside a right angle, they are equal to what? 90 degrees. Then the next one is sum of complementary angles. So we ask ourselves, what are complementary angles? Complementary angles are angles, so 4 complementary angles. Complementary angles are angles that add up to give 90 degrees. Complementary angles are angles that add up to give 90 degrees. For example, we say 70 and 20 are complementary angles. They are complementary to each other. Because if you add 70 to 20 to give 90, we say, for example, 50 and 40 are complementary angles. Do you understand? We say 85 and 5 are complementary angles. We say that 30 plus 30 plus another 30, they are complementary angles. Do you understand? We say 60 plus 10 plus 20, they are complementary angles. So once you see angles that when you add them together, they give us 90 degrees, they are what? Complementary angles. All right? Why supplementary angle? We say sum of supplementary angles is equal to what? 90 degrees. Okay? So first of all, it means that complementary angles cannot be more than 90 degrees. So a complementary angle cannot be more than, so it must be less than 90 degrees. Even 89
is a complementary angle because 1 can be added to 89 to give 90. Do you understand the point now? All right, so for supplementary angles are angles that when they add together, they give us 180. So don't forget it, complementary is for 90, supplementary is for what? 180. Supplementary is for 180. Why? Complementary is for 90. So for supplementary angles are angles, of course, they are more than 90, such that when they add them together, they give you what? 180. Do you understand? For example, 90 plus 90, they are complementary angle, they give you 180 degrees. 100 plus 80, they are supplementary angle, they give you 180 degrees, and so on. Okay? All right, so sum of angles in a triangle. Sum of angles in a triangle. So 5, we have talked about supplementary angles. So the next thing there is sum of angles in a triangle. I will quickly explain that to you. That is 6. Sum of angles in a triangle. If this is our triangle, if this is our triangle, and we have here A, we have here B, and we have here as well C. This property is saying that sum of all angles in any type of triangle, whether in scaling triangle, isosceles triangle, equilateral triangle, right angle triangle, whatever kind of triangle it is, okay? Sum of angles inside any type of triangle is usually 180 degrees. What that means is A plus B plus C is equal to what? 180 degrees. Don't forget these properties. We will have questions that we'll begin to solve and you'll see how they are applied. So sum of angles in a triangle is equal to what? 180 degrees. Now, I have other properties. I will have a diagram and give you. In a situation where we have two parallel lines, and we have, two parallel lines, and we have a transversal. Let's have a transversal line is a line that cuts a parallel line. Okay? So this is a transversal, and this is a transversal. Do you understand this now? So let's say we have something like this. This is a parallel line. Okay, let's say this is a parallel line. Okay, so let's say this also transversal parallel line going on their own. Meaning this distance is equal to this distance is equal to this distance. That's why they are parallel line. Okay, now we have the first one there, number 7. We said vertically opposite angles are equal. What is a vertical opposite angle? Vertically opposite what? Angles are what? Now, let's assume this is A, or let's start from here. This is A, B, C, D, E, F, G, H. Let's just use here. Look at those. These are angles now. We'll use this to form all the properties we are talking about here now. The first one says vertically opposite angles are equal. Now, if I will look here. Vertically opposite angles means that, let's say this is a transversal, then this is another transversal cutting it. If you check, if we have an angle here, this is A, and here, this is B. Let's assume that. Now, you understand that when we say something is vertical means line running from up down or from down upward, while horizontal is a line running from left to right or from right to left. Okay? All right. Now, vertically opposite angle means this shape, you can decide to turn it this way. This is opposite to this. Is vertically opposite. Okay? This is a vertical line. This, even if it's not a very straight vertical line, but you can take this figure and keep it like this, meaning you can actually have this thing like this. This can be taken like this so that A will be here and B will be here. So this is vertically opposite. Even if it is C and D, this is still vertically opposite because you can also take it this way. Do you understand me? Do you understand that now? So we say that when angles are opposite each other, they are vertically opposite angle and they are equal. So this is vertically opposite to this. Look at this. D and C. D and C are vertically opposite to each other. So we said, let's now go back to what we have here. In this first point, in this first angle, we have A, B, C, D. Angle A, angle B, angle C, angle D. Here we say A and B are vertically opposite. You see, A is facing the direction of C. So we said that A is equal to C because we say vertically opposite angles are equal. Remember these properties when we begin to take some, what is it called? Some problems. You will understand why you need to understand this first. Okay? All right. Why D and B, they are also vertically opposite. So we say and D, okay, B is equal to D. You get that? All right. So the next one is corresponding. The same thing applies here. The same thing applies here. E is of course equal to vertically opposite. Is equal to G, and F is equal to vertically opposite H. Do you understand that? Okay. So if we come down here, we say corresponding. The next what is it called? The next property says corresponding angles are equal 8. Corresponding angles are what? Equal. Corresponding angles are equal. What are corresponding angles? When we say something corresponds, it means it agrees. Do you understand? It agrees with what the other one is trying to say. So there is a correspondence in the way those things appear. All right? Now, corresponding angle here, if you look at this now, let me give you this angle here now. Let me give you this here and here so that it will be easier for us. This is a parallel line. So then this is a transversal line. Now, there is an angle, listen, there is an angle formed at the top of the parallel line. Let's call it angle X. If you look at this place, there is also an angle formed at the top of this parallel line. Let's say angle Y. Let's even come down. Let's say this is coming this way. Let's say an angle was also here. This angle was also formed at this top. Let's say Z. Let's also go down. Okay. This transversal line keep cutting. Let's say an angle is also formed here at the top of the parallel line. Let's say this is a UVWX. So this is W, all right? All right. So W, X, Y, Z. Now, if you look at these angles, the pattern, they have a particular pattern of formation. They are always formed at the top, of the what? Parallel lines. So we say that these angles are corresponding. So W is corresponding to Z, Z is corresponding to X, X is corresponding to Y, Y is corresponding to Z. You know, they are all corresponding angles because they have a particular pattern of how those angles or where those angles are. So we said that W is equal to Z is also equal to X is equal to Y. Why? Corresponding what? Corresponding angles. You always give your reasons when you're solving. Give your reasons for whatever you give. So this is corresponding angles are what? Equal. Look at, if I put something here, see, here, here, here. Do you understand? And here. So let's say this is A, this is B, this is C, this is D. I will say that A, if you look at this angle A, it is formed at the base of the parallel line. This one, the base of parallel line, base of parallel line, base of parallel line. So they have the same pattern. So they are called corresponding angle because they have the same pattern. So A is corresponding to B, corresponding to C, corresponding to D. Do you get the point? So we say that A is equal to what? B is equal to C is equal to D. Why? Corresponding what? Corresponding angles are what? Equal. You get that? So let's go back to what we have here now. Look at this. Here we have B corresponding with F. You see? So we say B is equal to F because corresponding angles are equal. So B is equal to F. You get that? Now, look at A. Look at D. D is corresponding to H. C is corresponding to G because it is at the top here, at the top. E is corresponding to A because it's at this particular part, So we have corresponding angles in all this. Do you understand me now? Then the next one is alternate angles are equal. What is alternate? Let's quickly look at that. That is the next property. Property number 9. Alternate angles are what? Equal. Alternate angles are equal. Now let's look up. If this is our horizontal line, these are horizontal line, and these are transversal. Okay? Now, this is A. This is our A. Alternate means the opposite, the other side of something, the opposite of something. Okay? So the alternate side of this A is here. Let's say this is B. So this A is the alternate side of this is this. So it keeps alternating, changing. That is changing. Do you understand? So if we have, let's say, let me draw a better picture. Let's say, let's have here and let's have here. Let's have plenty alternate angles. So let's say here we have here A. Let's say here we have A. The next alternate will be here B. So this is it. You see? So if we have here C, alternate here will be D. If we have here E, alternate here will be F. Can you see? So alternate is just the change in position of a particular angle, the other side. Okay? So this is alternate to this. This is alternate to this. This is alternate to this. So we say that A is equal to B. Why? Alternate angles are what? Equal. We say C is equal to D. You see that? We say E is equal to what? F. All those things are what? Alternate angles. Okay? All right. So this thing we have here, this B is equal to E here. Sorry, this C is equal to this E here. So we say they are what? Alternate angle. This D is equal to this F. They are alternate. So alternate can be either from this side or this side, or from this side to this side. Okay? They are alternate angle. The next one is two adjacent angles add up to give 180. Adjacent angles are similar to angles on a straight line. What are adjacent angles? 10. Two adjacent angles equal to 180. That's their sum. Let's say this is two parallel lines. Okay? Do you see this? So let's say this is A. Adjacent means something that is beside something. Okay? A. If we put B here, this B is beside A. So this B is adjacent to A. So remember, this A and this B, they are on a straight line. That's why I said they are similar to angle on a straight line. Do you understand me now? So B, A and B, they are adjacent angles. So we say A plus B is equal to what? 180. Why? They are adjacent angles. We can also have that here. If we have, let's say here we have C and here we have D. They are also adjacent angle. Remember, see the straight line now we are considering, and they are on this straight line. So C plus D is also 180. Okay? Then the last one which we'll look at today is interior angles add up to what? 180. What are interior angles? Angles appearing in a particular side of a shape. Okay? Interior angles number 11. Interior angles add up to what? 180 degrees. Interior angle add up to 180 degrees. Let's see what interior angles say. This and this, we have this. So interior angle here will be, if this is, let's say A, and this is B. This you see these figures we have here, they are found in one particular part of the equation. So they are interior angles, meaning that they are inside one particular place. Do you understand me now? These are interior angle of this secluded shape that we have formed now. These are interior means inside. So these two angles are inside a particular area. Okay, it means that A plus B is equal to 180. The interior angles. The thing is that if we also have another interior angle here, let's say this is an interior angle. Let's say this is C and this is D. This and this also will be C plus D is equal to 180. Now, can you see why? If you remember, maybe we'll also look at it when we start to look at quadrilaterals, or when we look at polygons rather. We see that some of angles, this is a quadrilateral having 4 sides. 1, 2, 3, 4. And these angles are interior angles in a quadrilateral, or interior angles of a polygon. What is the name of this polygon? Quadrilateral. We say some of interior angles is 360. How? Because when we didn't put this one, this was 180. We added this one now to make it a secluded shape. It's another 180. So 180 plus 180 gave us 360. So sum of two interior angles is equal to 180 degrees. Okay? So if we have something like that, so this is 180 degrees. So if let's say here we have C and here is D, it means that C plus D is equal to 180 degrees. So once they are found in one particular side of the equation. So I think with these few points, you have understood the properties of angles, definition of angles. The next time I will meet you, the next time I will come your way, we will use these properties to solve mathematical questions on angles. And you will have to apply them to get the answer. Thank you so much. See you next time.